using the velocity ratio. Give me the value of capital D. 1440 into 280 divided by 480. So 840 is the value. Now, do you think again this has to be standardized? So if this should be standardized, it would change its value. If it changes its value, the velocity ratio would get disturbed. Yes or no? So changing velocity ratio, in the sense you are changing entire belt transmission system. That is not recommended, no? So don't standardize this value, just write a note there. Is not standardized as it leads to change in the velocity ratio. So capital D we have found out as 840, and please do write this particular note in your notes, saying that we are not going to standardize this value just because it changes the velocity ratio being, since velocity ratio is given in the problem. Okay, done. Next you have to calculate length. So in order to calculate length, first you have to decide whether it is an open belt or a cross belt. So in this particular question, whether it is an open belt or it is a cross belt arrangement, which one it is?
Open. Open belt.
How did you come to know that? How did you come to know that? How did you come? Diagram, simple, very good. So just calculate C now. Since D is calculated as 2 times D, which is given in the problem. So 2 times of 840 is 1680. Now pick the formula to calculate the length. Substitute all the things, capital D, small d, and C, and give me the value of length. So all is a repetitive, man. Pretty easy, no confusion, nothing. Simple, straightforward questions. Just like physics, chemistry questions in your second view. No twists and turns in belts. Very few will be there. Same procedures. Oh. Okay, so 5165.95. So can I take it as 5.16 meters, or can I take it as 5.16 meters? Next. Yes, the answer is correct. Now, immediately move on to the calculation of width. For width, what do you require? For width, what do you require? How do you calculate width? Using which expression will you calculate the width? Anyone? Using which expression you will be in a position to calculate the width? However, so pick that particular expression, BTV expression, BTV divided by 1000 expression there. Okay, So before to that, calculate the velocity since it is required. Why you are calculating this velocity since already it was given? Anyone? Velocity was given in the problem, no? Correct. Koಟ್ಟಿದ್ದು ತಾನೇ on velocity 20 meters per second. Again, why you are calculating velocity here? Anyone? Yes, incorporation of the thickness one. Since capital D was calculated in a NIP and it was standardized. Standardized value we have taken, no? We have standardized the value, no? Definitely there will be a change in velocity. So that's why we are calculating velocity once again. That's it. Okay. Use the same old formula to substitute all the values and get the value of B. So you might have required to calculate the theta value. Also use that expression to calculate theta S there. It would be 2.81 radians. I have written there directly. So substitute everything and give me the value of B now. Take your time. Snehal Sheikh. Snehal. Snehal Sheikh. Not bad. ಅಲ್ಲಿ ಹೋಗಿ ಕೇಳ್ಕೊಂಬರ್ಬೇಕು ಫಸ್ಟ್. Can I get the standard width? Okay, 125, isn't it? Okay. So it is 125. Shannon is good. Now, I hope all of you know the procedure to calculate tensions. The specialty of the design classes, I need not speak much because already the procedure will be known. You have to solve it. Okay. Um, so how to find the belt tensions? You might have to use the two formulas. One is the power formulas where it says it is T1 minus of T2 into V. They will get an expression of T1 in terms of T2. Later you have to use the e to the power of mu theta T1 by T2, that particular formula. So again you can replace T1 with T2 that, so you can get the value of T2. Same thing you have to use that. First use this particular formula. Okay. So this particular calculation of belt tensions would be there in every problem, guys, every problem. So first you might have to use this particular equation which includes the power. Second, you might have to use this particular equation which includes the value of e to the power of mu theta. That's it. Compare those two equations, simple mathematics, you'll get the values of tensions there. Arjun E. Arjun,
Yes, sir.
are you there? Arjun,
Yes, sir.
solving the problem. Okay. T1 value 1387. So 1387.37 Newton, and it is 691.64. So few messages have given Harshit, Hashir, Hazim, Kishan Kotian, Lucky, Rakesh GM, Ramachandra, Syed Anwar, and Sohan. Please stay after the class. So once after the class also, please do stay in the class. There is some work to do. Okay. Now, what is the value of TC? To sub 275.99 in the sense it can take it as 276. 276. There are 2-year students, second year students. I did not get you, man.
They're not from our class.
Snehal said is not from our class. Then how did they come here? Snehal said is from our class. Who are there? Can you let me know, Ritvik?
Sir, you mentioned in the message, no, sir. No one is from our class.
Oh, sorry, yes. You are right. You are right, dear. I'm sorry. This is for the fourth semester. Correct. These people, Fawaz, Gagan, Mohit, and Sagar. Please do stay. Okay. Even Ruhail also. So all these people, please do stay. Okay. Is that clear? Yeah. So this completes the problem. Now, till now, whatever we have discussed, no, those are normal numerical problems. From now on, we will follow the exact design procedure, exact design oriented problems. We will see how those problems should be. Relax for another 2 minutes. I will come back. Okay. Are you able to see the screen now? Yes?
Yes, sir.
Okay. So, so in the projects also, your final year projects next year, you're going to do that, isn't it? You might have to design a belt if there is a requirement in your project. Or in any case, if you join a certain industry, you will be in a position to design a belt for that. Okay. So in such situations, in order to design a belt, you have decided upon to design a flat belt. Then what is the exact procedure that has to be followed is being portrayed in the form of design procedure for flat belts, one by one, step by step, each and everything neatly given here. Okay, all this design procedure is there. It consists of 11 points and nothing new. Few decision making strategies are there, few decision making strategies at the initial level, and remaining after once the problem proceeds, all the parameters you have already calculated. For example, width, it might be belt tensions, it might be length, it might be arc of contact, all the things you have already calculated. Again, you are going to calculate and standardize in the form of design procedure now. Okay, so this is a standard procedure what we follow in order to design the flat belt systems. Is that fine? So what shall we do? Shall we just recap this procedure, or directly we shall go to the problem and solve one by one and get to know the things? What shall we do? Because it's all theory, man. If I say keep on saying it, all the points you will never understand. That is what I feel. So while we are solving the problems one by one, I'll be just revealing the points, what has to be decided and what basis you have to decide and so on. Okay. So shall I just quickly revise this design procedure, or shall we directly move to the problem and get to know the things there one by one? What shall I do? Yes. Revise. Okay. Fine. So don't worry if it feels very bulky to you. It's very easy in fact. Okay. So first, before you start a design procedure or designing a belt, you have to make certain preliminary decisions. For example, number one, the material used for the belt. So which material are you going to use for the belt? Generally, we use oak tanned leather or mineral tanned leather. Tanned in the sense soaked leather. Okay, oak tanned and mineral tanned leather with design stress value to be 2 megapascal. So if nothing is given in the problem, if he has specified certain material, we can pick the value of design stress. Or if he has not specified anything, what you have to do, you have to just go with oak tanned leather, where it specifies the design stress as 2 megapascal. Now, once the material for the belt is decided, now we have to decide the material for the pulley. Generally, you take cast iron because it has got good damping. It is not damaging property. Man, I'll just change this. It is damping property. Damping in the sense absorption of the vibration. Damping is that property where it helps you to absorb the vibration. So generally we use cast iron pulleys just because it has got good damping properties. Now you have decided upon the pulley material. You have decided upon the belt material. Now once you've wrapped the belt, you need to join it with a certain source. Correct? This belt has to be joined like this. So which type of joint are you going to use? Whether you're going to use a cemented joint or which type of joint will look here. So the type of joint required, generally use cemented joints. Cemented joints has got joint efficiency of 100%. So from where you can get the data, all of you just refer the table number 14.5, page number 307. There are different types of joints are given. For example, 407, where is that? 307, not 407, huh? 307. So here it is. Type of joint. We always use cemented joints and consider the joint efficiency to be 100%. Okay. So all the other joints, if we have specified, hinged, wire hook, laced, if we have specified anything in the problem, then you have to take the corresponding higher efficiency value. Okay. If he has not specified anything, what you are going to do? You are going with the cemented joint, which is 100% efficient. Next, the service condition. So service condition in the sense on what basis your belt is running. So your belt is there now. I'll just pick this up and move on throughout the session like this. Now your belt is here. You have decided upon the joint. You have decided upon the material of the pulley. You have decided upon the material of the belt. Everything is done. Now, what is driving what? What is the driving member? What is the driver member? How far it is operating? Whether it is operating continuously? How clean the environment is. Based on all those, you have 5 factors: C1, C2, C3, C4 and C5. You can get these values from 14.8310. 14.8. These are the conditions. Okay. So these are different factors to which you can decide upon. For example, from here you can get the value of C1, which describes the atmospheric condition. Whether it is, if it is clean, you are going to take 1.2. If it is normal, you are going to take 1. If it is oily, wet and dusty, you can take 0.7. So basically you take the value of C1 from this. Now you take this value of C2, angle of the center line. But that means if the belt is straight, if the belt is straight, you will take horizontal to 60 degrees, you will take the value as 1. If it is inclined something like this, then you will take this particular value based on the given condition there. You will take the service factor. Next, based on the pulley material, whatever you are using, you are going to take the value of C3. Service condition, how continuously you are operating the things up, whether it is operating temporarily, normal condition in the sense 8 hours per day, important continuous in the sense it should never stop. It is an important machine. The belt should never stop in the sense you have to go for continuous. In such cases, based on that particular application, you are going to take the value of C4. Next is the value of the peak load. Yes, any doubts? Next is the value of the peak load, from which you are going to take the value of C5 based on the motor pulley, which is electrically driven. Based on its diameter, you will pick the value. Or if it is a, you have to see here, if it is a diesel engine, you have to take 1. Steam turbine, you have to take 1. Okay. Reciprocating machines, if it is there, if you have to take 0.8. Based on those conditions, you have to pick the value. Once you have picked all these values, you have to multiply all these values. For example, it is C1 cross C2 cross C3 cross C4 cross C5. All conditions will be taken. You have to multiply all these values. Then you'll get the value of CS. Okay. So if nothing is specified, like how the normal cleanliness condition is there, whether it is inclined or whether it is horizontal, what is the driving member and driven member, if nothing is specified, you can directly assume it to be a 0.2 straight away. Getting it? If something is specified, then you have to pick all these values, multiply that to get the value of CS. Understood here? Any doubts in the calculating the value of CS? Any doubts here?
No, sir.
Okay. So that is the story behind the value of CS. Okay. So once the value of CS is known, you have to calculate the design stress. So just you have to multiply the value of CS with the power value which is given in the problem. You have to multiply it so that you will get the value of the design stress. So design stress completed. So once you have calculated the design stress, your first step, which is making the preliminary decisions, would be completed. So first step is what? First step, ends where? Ends at calculating the design stress. So second step is calculating your diameters. Diameters in the sense you will use this particular formula from 14.9a, page number 292. You have the value of PD. Omega max you can calculate, it is 2 pi small n max. Small n is nothing but capital N by 60. That is nothing but in the RPS. So if you substitute, you will get the value of the diameter. Okay, don't worry about this step down and step up. It will confuse you. Once the problem, we are solving the problems, then we'll teach you what is exactly step up. So this is step up and this is step down. So what exactly it is and why it is important, I'll teach you once the problem is arrived. So just understand now. In the step number 2, what are you going to calculate? In step number 2, what are you going to calculate? Yes. What you are going to calculate, man, in the step number 2? Yeah. Respond, man. Okay. Then you will use this particular expression to calculate the another diameter, which is capital D. So small d you have already calculated. In the step number 3, you are going to calculate the major dia. Okay. Major dia, you use this particular formula. There is only one, this is old formula, man. Capital D by small d is nothing but I. No, I is nothing but velocity ratio. For this, you are adding this particular factor. So this value of epsilon is known as a slip. Okay, slip or creep in belt. It is generally 1 to 3%. Generally, you will take it as 2%. While I was solving my problems, so generally I take 2% slip. Okay, so I just write 0.2 there and calculate the things. Okay. This is how you calculate the major diameter. Step number 1, you will calculate the power, design power. Step number 2, you will calculate the smaller diameter. Step number 3, you will calculate the major diameter. In the step number 4, you are going to standardize the pulley diameters, whatever you have calculated in step number 2 and step number 3, using the table number 313. Already you know that. Already you have seen this particular table. So once the diameters is being calculated, now you will calculate the velocity. So in the step number 5, in the step number 6, you will calculate the center distance. So center distance is given by 2 times of d plus d. Okay, so you'll calculate the center distance in step number 6. Step number 7, you'll calculate the value of MIF. So using the Bath's formula, this particular formula is already used in case of gas. Hope you remember that. Same formula is given in the data handbook also. You can pick that particular formula and you can calculate the value of MIF. Okay, you know this particular parameter. So if V is greater than 10 meters per second, you are going to consider the centrifugal tension. Okay, length you are going to determine in the step number 8. You are going to determine step number 8 using these equations, whether considering it as an open or cross belt. Okay, angle of contact, you can use these expressions to calculate angle of contact. Same, pi minus capital D plus small d divided by d. So that particular expression you can use to calculate your angle of contact. So once the angle of contact is being calculated, next you have to calculate the width of the belt by selecting the suitable thickness. So see, first B and T both will not be given in case of a design problem. So first you have to assume the value of suitable value of T, then you can calculate the value of B. So assume a suitable value of B. So again, it's the same problem. The only change, you are going to multiply it with the joint efficiency. This is very, very important. Okay, you have to multiply the whole thing into joint efficiencies. Majority of the problems, it could be 100% plus in some cases, if you have specified some specific joint, then you have to pick the value of specific joint efficiency there. So Again, same old problem. You can just calculate the value of B from here and standardize it. The relationship between the diameter of the pulley and the thickness is given by this. You can use this is a thumb rule. Generally, the smaller diameter divided by thickness of the belt should be lesser than 50. So this is what designers follow as a thumb rule to have a proper arrangement. Okay, so D minimum divided by T should be less than 50. From this, it helps us to assume the value of T. You can just cannot just assume random value of T, just 2 mm, 1 mm ಆ ತರ ಹುಚ್ಚುಚ್ಚು assume ಮಾಡೋದ ಹಾಗೆ ಒಂದು thumb rule ಇಟ್ಕೊಂಡು ನಾವು assume ಮಾಡಬಹುದು ಇದನ್ನು. Okay, so D minimum by T should be lesser than 50 according to this thumb rule. You can calculate the value of thickness. 11, you can, step number 11, you might have to calculate all the belt tensions including T1, T2, TC and T0. All the tensions you might have to calculate. I told you 2 different formulas. One is the power equation. Second one is the e to the power of mu theta equation. Both the things have T1 and T2. Compare these two, you'll get the values of T1 and T2. So once the value of T1 and T2 is known, lastly, you can calculate your initial tension and end your problem. So there completes your design procedure for the flat belt drive. Clear? Any doubts? Any doubts? Not only Arvind, what about others? Any doubts? Okay. ಎಲ್ಲರೂ ಅಷ್ಟು ಪರ್ಫೆಕ್ಟ್ ಆಗಿದ್ದಾರೆ ಡಿಸೈನ್ ಅಲ್ಲಿ ಒಂದೇ ಕ್ಲಾಸ್ ಅಲ್ಲಿ. ವೆರಿ ಗುಡ್ ಮ್ಯಾಮ್, ವೆರಿ ಗುಡ್. ನೋಡೋಣ ಎಷ್ಟು ಪರ್ಫೆಕ್ಟ್ ಆಗಿರ್ತಾರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಅಂತ. ಸೊ ವಾಟ್ ಐ ಪ್ರಿಫರ್ ಇಸ್ ಯು, how should I do? Shall I send this design procedure to you? Will you update in your notes or will you take a screenshot? Will you take the screenshot? Okay, good. I'll just tilt it up. Shall I put it in the portrait mode? This is better or previous one is better?
Upload, sir.
Portrait is better, right?
Sir, can you upload it into the classroom, sir? It will be safe over there.
Okay, I will try to upload it. What is that page? Okay, just check your Google Classroom whether it is posted or not. Yes, please give me a confirmation. Anyone?
Received, sir.
Yes. Now, all of you just scan today's classwork and submit in your Google Classroom. So by the next class, please update your design procedure because you might have to frequently look at it. Okay. In your notes, So from the next class, we'll be solving the first design problem on the flat bench. Is that fine? Mark your attendance in the Google Sheet, update your classwork, and leave the class. That's all for today. We'll meet up in tomorrow's class. Okay? Classwork 10, 0, 6, 21.
Radhik.
Assign. Okay. ಒಂದೇ ನಿಮಿಷ ಅಪ್ಡೇಟ್ ಮಾಡ್ತಾನೆ. ರಾಜ್ಬಿಕ್ ಮಾರ್ಕ್ ಮಾಡಿದ್ದಾನೆ.
ಹರ್ಷ ಸರ್.
ಹರ್ಷ.
Prashant sir, 112.
112. ಅಪ್ಡೇಟ್ ಮಾಡಿದ್ದಾನೆ.
ಸರ್ 126.
126 ಸುಧಾಂಶು ಅಪ್ಡೇಟ್ ಮಾಡಿದ್ದಾನೆ.
Sir 128.
128 ಸುಜಿತ್ ಅಪ್ಡೇಟ್
Thank you, sir.
ಮಾಡಿದ್ದಾನೆ. So few names I have told to be stayed back. For example, Fawaz, Gagan, Guga, Mohit and Sagar. Please do stay back and others can leave, guys. Only these people please do stay back. Fawaz, Gagan, Mohit, Sagar and Rupail. Fawaz, are you there?